In this lesson, we're going to learn about a pretty useful tool called sketch constraints. Sketch constraints are like the enforcers for your different sketch figures as you create 2D sketches, and they do two fundamental things. The first one is they make two figures or more figures act in a particular way. For example, make them equal, make them perpendicular. This serves the second thing that they accomplish, which is it makes editing a whole lot easier and removes the number of dimensions that you need to fully define your sketch. Let's take a look at how this particular 3D part was made. We'll edit the sketch that was used to create the extrusion. And we can see we got a lot going on here. Now this is a perfectly valid way to create this part. Every hole has a dimension. The center point for every hole is dimensioned off of the sides. Both of these radii are dimensioned on the slot. And you could do it this way. But let's say you need to make a change to something, right? We want to modify the size of these holes, maybe. So we're going to go type in 0.5, and now we got to go to this hole and type in 0.5, and go to this hole and type in 0.5, go to this hole and type in 0.5. And as part of this change, we also need to change the offset, right, of each of these holes. So all of a sudden, you're not only touching like dozens of different things, but you might miss one. And what happens then, right? You go to production and all of a sudden one hole out of 30 is the wrong size. And now you've wasted a bunch of time and money. So there is a better way to do this. And the better way is using sketch constraints. So we're going to remake most of this part, but we're going to use sketch constraints in the process and kind of show you what that looks like. So let's start making this part using some constraints. We'll start with the rectangle by center tool, and we'll just kind of drag it out. And we do need some dimensions, right? Constraints don't fully replace dimensions, so let's go ahead and set this to be maybe 11 by maybe, I don't know, 8. And now what we want to do is create some circles. So we'll just start making some circles, and we don't really care, right? We're not trying to get it precise when we place them because we're going to do that later. So the first thing that we know about all these circles is that we want them all to always be the same. So let's click on the equal constraint, and we'll just start selecting them in a row. And we see a little equal constraint is applied to each of them. And now if we were to change the size of one, all of them are going to update automatically. Very cool. Now the other thing that we know is that we want these all to be lined up horizontal and vertical from each other. So a pretty easy way to do that is to use the horizontal constraint, which can apply to lines, but also to nodes. And in this case, the nodes are our center points. So we'll left click one and left click another, and we'll click an empty space to clear it, and then we'll do that with the next set. So now if we move one up and down, they both move up and down. And the next thing that we might do is create a vertical constraint in the same way. So maybe we'll add this vertical between this node and that node. We'll left click to clear, and then we'll do the same thing over here. So now all of a sudden, we're starting to build in some design intelligence, right? We know that these are always going to be in the corners, that they're always going to be vertical and horizontal from each other, and they're always going to be the same size. And now, without adding any dimensions, we're representing the design intent of all those criteria by using some constraints. So now let's go ahead and add a dimension. Now we're ready to do that. All right, we'll left click and we'll say this guy's going to be 0.6. And they're all now 0.6. The other thing we need to do is to figure out the offset from the sides. So we'll say maybe this is an offset of 0.8. And maybe from the top, it's 0.8. We can see that when we do that, some other things have happened. This one has moved also, and this one has moved to the left. So we have to create a few more dimensions. And the last thing that we need to do is, because we created this rectangle by center, we need to just add a horizontal or a vertical constraint to one of the sides to make it not able to move around the center point. So let's do that. And now we can see that our sketch is black, which means it's fully constrained. Instead of having, 1, 2, 3 dimensions for every circle, now we have one that has 3, but the rest just need 1. Right? And there's other ways that you could accomplish things like this. You could use symmetric constraints, and that would certainly work too. The key takeaway here is that constraints enforce rules between things. But different kinds of rules that constraints can enforce, you can see them all if you just hover over the constraint section. So first we have symmetric, which will make two items symmetric. We have the corradial constraint, which will make multiple arcs share the same center point and the same radius. We have collinear, which makes two things go into a line. The ever popular equal constraint, which can make lines, arcs, circles equal to one another in size. Vertical and horizontal can be used on lines and on nodes between two nodes. Same thing with horizontal. The intersection constraint will put a node on the intersection of two other objects. Concentric will make one or more circles or arcs or combination of them all share the same center point. Perpendicular will make two figures perpendicular to each other. The midline constraint attaches a node to the midpoint of a line. Tangency will enforce tangency rules between circles, arcs, and lines. Parallel will make two objects parallel to each other. And then the coincident constraint will attach one object to another object. We'll go into constraints in a lot more detail over the course, but just be aware that using a combination of dimensions and constraints is what's going to be the most efficient way to create parts. So building your design intent where you know it, quality between circles, for example, would be design intent. And then take advantage of that design intent by creating fewer dimensions to drive the part.